And welcome back. Now today I'm just going to talk to you about something that I've ordered. I mentioned it in last week's video actually. It's this remote control volume. So basically it's a potentiometer here connected to audio signals with a little tiny motor on the back, that little round thing at the back. We'll have a close-up on this in a minute, but I want to show you it working first. Yeah, and it just turns that motor when you press these buttons here, plus or minus, and it does the volume. It runs off, it says here, 9 volts AC. I want to give a shout out to PCB Way, PCB Prototype the easy way. Just enter the dimensions of your PCB, choose the number of PCBs you want and the layers, and hit the quote now button. Now it's all very well for me to promote PCB Way, but look at these two boards. Now these are two of many that PCB have made for me. This is quite a simple one, and this is a bit more complicated. In fact, this is an assembled PCB Way board. Let's look at these under the microscope to look at the quality of these products. So here I'm looking for the quality of the drill and pad placement, and as you can see here it's totally 100% accurate. We have a track coming down the middle, there's the hole, and the pad around it, the soldered pad, is exactly where it should be, and this is replicated throughout the entire board. It's absolutely spot on. Now this was a board I asked PCB Way to make for me because it was small, fiddly, and frankly the components on here were so tiny that I didn't know if I was going to be able to solder them or not. Look at that crystal Y1 down there. I mean, that is absolutely tiny. I'm not sure I could have soldered that, so it's just as well PCB Way did an absolutely outstanding job on here. Why don't you have a look at their website and try them out now? It runs off, it says here, 9 volts AC. I don't know if, no, I don't want to touch it. 9 volts AC, but on the actual page from Banggood, it does say AC stroke DC. So DC is what I've plugged in. Now AC is it's a little bit awkward AC, because if it says 9 volts AC and you actually have a transformer that you plug in or something, or connect to the mains in some way, and it says 9 volts, I bet you that if you were to measure that with your multimeter, it'd probably say 14, 15, possibly even higher, because the 9 volts AC is at the rated load. So if you've got a plug-in thing that says, let's just say for argument's sake, 9 volts 1 amp, it means you can take 1 amp from that transformer and then it will be 9 volts. Off load, or very little load, that voltage will increase quite a lot. Which is why when you convert AC voltage like that to DC, you do have to regulate it quite a bit. A non-regulated power supply could easily blow up, well, for example, your Uno, or this, or indeed anything. So an example, you think, right, I'm going to plug 5 volts into my Uno. Here I've got a little plug-in thing that says, oh, I can select various voltages, 5, 7, 9, 12, whatever, but it's unregulated. So once again, it means 5 volts at the 1 amp or half an amp capacity. But what you don't realise is it's 5 volts goes up to 9 volts when there's no load. So we really do have to be a little bit careful about that. I'm just being a bit distracted. I'm sure I just saw a spider fall down actually from my ceiling. I don't know where it's gone. If I leap up, you'll know that it's found me. Oh, it's on me. Look, it's on my hand. I'm not lying. There it is, look, running across my finger. That's a money spider. What are you supposed to do? You're supposed to whiz it round your head 3 times, aren't you, and then let it go? Yeah, well, I'm sorry, spider, I'm not going to let you go. I'm just going to let you off my finger. Come on, off you go. Right, let that run around the workbench for a little while. You can learn a bit about Arduino stuff as well. Right, so anyway, 9 volts DC is coming in here. Now it's a bit silly because it's going through a regulator and a rectifier and smoothing capacitors, none of which it needs, of course. Well, the regulator it does, because the regulator brings the 9 volts in here down to 5, which is what this needs, the chip on there. Oh, now you see, look, I'm moving stuff. I didn't want to do that. Anyway, there's a chip down there. We'll have a close look at this in a minute. There's a chip on there that requires 5 volts, and the whole thing runs on 5 volts. So it's converting the 9 volts I'm putting in here now down to 5. And it's working okay, but I think, if I was to build this into something, would I do it differently? And I think, yes, I'd probably have a 5 volt stabilised supply going straight into the 5 volt pin, but I don't think it makes a huge amount of difference. The great thing is that the volume control, of course, is electrically isolated from all of this. So all this business here, turning the motor and everything else, has zero impact, absolutely zero impact on the connections to the potentiometer, which is great. And in fact, the ground and all that for this, for the potentiometer, is totally separate from the ground from here, which is exactly what you want. So isolated to the nth degree, no noise comes across. That's the thing. You don't get any noise, hum, buzz, anything. Great. Now you can see it just about working. I haven't got, would you believe, I know this is incredible, I couldn't believe it myself, I haven't got a knob that fits onto this sort of spindle. If you notice this spindle, look, it's got a slight cut at this level here, and then it's round. I think they call it a 6.3mm spindle, but all the ones I have are ones with those serrated knobs, and they just slide on. So I haven't got one that fits, but I've ordered one. A nice, well, it looks like aluminium, but I think it's plastic actually. But anyway, you'll see that if I hold it like that, so you can see the flat bit there, you'll see it go around when I press this. If I go less, now look, there it goes round, see that? And the light's flashing over there. That's as far as it will go, and then of course press it up again and it goes around the other way. Now the other good thing about this is that if you disconnect the power, on power up, it turns it round to about, well, what I'd call the 9 o'clock position. Oh yes, by the way, you can of course turn this potentiometer manually if you want. So I can just turn that, no trouble at all, and all that does is turn the motor round the back without any damage or anything else. But when I switch off, and I'm going to disconnect the power, because I've got it on a little tiny connector here, you notice. So if I turn that off, now you see where the potentiometer level is at the moment, just about the flats on the left hand side there. When I connect up, that will turn, and I'll try and whiz the motor up so you see it. Look, it's turning back all by itself to about what I call the 9 o'clock position. Oh, in fact, it looks like it's fully minimized actually. So on power up, if you were to disconnect all the power, say to your hi-fi, whatever it is, and then turn it all back on, instead of being blasted at the last volume you had, it actually moves it down pretty quick. So that's great. It's a nice little sort of safety feature, I suppose you'd call it. Now, there's one other interesting little feature, if you like, on this, before we come on to the major bug that I found. Anyway, that's coming up. There's a 3-pin socket here for a relay. It's no good. I'm going to have to bring this forward, aren't I? I'll try not to disconnect these DuPont cables. So there's a 3-pin socket there, standard. What do they call these sockets? Oh, I can't remember. Anyway, it's polarized, but I'm just using DuPont cables for my testing. And it says on ground 5 volts. Now what that actually is, it says it's for a relay. If you look at all the comments on the Banggood site where I bought this from, well, you might as well see that actually where I bought it from. Here it is. Oh look, it's on offer. I paid, what was it, $15, $16 for it last week. Now it's on for 10. Oh, so annoying, so annoying. Anyway, so that's what it is. It's $10. Now what it says in the comments under all this is that that little socket is for a relay, so that you can turn off the main amplifier or whatever else you want to turn off, right, via a relay. And I looked up the circuit diagram for this particular unit, not to be found. Nowhere does a circuit diagram for this, but I did go onto AliExpress, and they have variations of this volume control thing with an ALPS potentiometer, so a quality potentiometer. They just have sometimes just the pot, sometimes just the power supply, sometimes the control board separately. I still couldn't see a relay, I must admit, but there did seem to be a relay connected to the power supply. Whether it's the separate one or not, I don't know. But we don't need that. What I've experimented with and what I've found out about this connection here, I'm thinking, how can I connect that up to not necessarily an Arduino, but perhaps like a home automation system, so that it can detect whether this is on or off or whatever, because you turn it off. Watch that LED if I press the off button. Oh, come on, there we are. So it goes off, right, and then on again. I reckon that could probably be some kind of you know, Node-RED MQTT type something. And if that means nothing to you, don't worry about it. It's just some home automation protocol that you can use. Works really well. Use a Raspberry Pi as a sort of controller. I haven't got anything like that running yet, but I thought, well, it could be used for that. But in the meantime, let's just connect up a simple little circuit to here to see what it does. And I'll get my whiteboard out first so you can see what that circuit looks like. Right, what I've discovered then is there's a chip on the circuit board that gives out 5 volts when we switch the whole unit off. That goes via a 4K7 resistor to the base of a transistor. This is an NPN BJT transistor. That's an NPN. That is the open collector, so nothing's connected to that on the board. That in fact is connected to one of the pins that you saw. Okay, so that's that one there is on, that one there is ground, and that one there is VCC. I think I've got that the right way around. So what we can do then is connect something between VCC and on to prove it works. And what I'm going to do is connect from VCC, so coming out of here it's going to be a resistor, probably 180 ohms or of that ilk, and then an LED just to prove it all works. LED coming out, there we are. So that will go to on and that will go to VCC. So it's like connecting something, isn't it? From here, VCC, down here like this. Basically, that's what we're going to do, just to prove that we can get this transistor to conduct. Okay, right, now you've seen what it looks like technically. Let's connect this whiteboard with 2 cables onto that. I'm going to have to do it off camera because I can't really see what I'm doing. So let me do that first and then I'll come back to you. Okay, right, it's connected. So all this is, as you saw, it's just an LED with a resistor, and it's connected from VCC plus 5 volts to what is that on connection there, which is in fact the open collector of the transistor. So if I press this off now, there we are. Look, that one there is blindingly bright, even for me. It's ridiculously bright, but there it is. So that goes on. The transistor conducts when this is off. However, if you press the volume control now, it still does something. Look, you can see it going flashing, flashy, flashy. Right? Even though it's still conducting, because you haven't said on yet. So even if you were to switch off your main hi-fi, say, via this mechanism, the fact that you're touching the volume control will have no effect because your main hi-fi isn't on. If you press this on again, there we are. Now that's off and this is on, and the volume control reacts as you would expect. It's an interesting little thing. I'm just trying to wonder what I can do with this. You know, I've got that valve preamp on order. It hasn't arrived yet, but I'm expecting it soonish. I'm wondering if I could use that to switch the valve preamp on and off, and then use this as a secondary volume control for the Amazon Echo that I have coming in via Bluetooth. Yeah, I know it sounds all a bit, you know, Heath Robinson-ish, doesn't it? But, you know, I have these ideas and maybe it'll work, maybe it won't. But, yeah, so all this is at the back, by the way. These are 2 little dip boards, adapter boards, where you can plug in your audio. So that's an audio jack, right? Audio jack there into this little dip thing that plugs into the board, and then I've got DuPont cables coming out, and then another one for the audio out, exactly the same. Just makes it easier to test things out. Cool, I think that's pretty good. Now, so what you're thinking now is, that's not bad, you know, it's $10, remote controlled volume control. Sounds like a good thing. Any problems, Ralph, you're saying? I'm glad you asked, because when I did this relay thing, and I had to sort of reverse engineer it to do it, you know, find out how it was working and gleaning tiny little tidbits and then get my multimeter out to find out what was going on. Now, if I bring this nice and close, we've done the demo sort of, haven't we? So it should be okay. You see, let me get my pointer as well. That little transistor down there, that is a standard NPN BJT transistor. It's an SMD one. That's why it looks, you know, different to a T092. And it's driven by pin, well, the second pin down from the top. I can't quite work out. No, I can't see that chip. But anyway, it's that pin there. So when you switch off, that pin goes high. It turns that transistor on and therefore conducts. So I thought, oh, right, okay, that's the way it worked. Connected it all up. Do you think I could get that LED on? No. I thought, well, what is it? I changed the LED, I changed the resistor, I put my multimeter on it, nothing would happen. So as Sherlock Holmes says, when you've eliminated everything else, the thing that remaining must be the answer. I paraphrase, obviously. Oh, look, that's the proper quote. But anyway, what it means is, no matter how stupid you think it is, but it can't possibly be that. But I thought there's something wrong with that transistor. If everything is happening, and I've tested that the base has got to the output from that chip that my thumb is now conveniently covering, it should be conducting. Why isn't it? It must be faulty in some way. So I thought, well, before I rip it off, I'll just resolder those 3 pads. Yeah, I know. I have to resolder those SMD pads. Oh, that was fun. Anyway, I did. Solder them up, or resolder them, just a bit of flux. I put a bit of flux on the pins. Got my little gull wing tip on my Weller soldering iron. That's not a Weller, is it? It's a Weller soldering iron tip. But my soldering, I can't remember what the name of the soldering iron manufacturer is. And it just touched each of the pins so that the solder reflowed. Plugged it all in, and guess what? It worked. So there's obviously a fault there in that particular bit of reflow soldering, I guess. There's nothing wrong with the transistor at all. Yeah, anyway, then it sprang into life. But I did think, I wonder if these are like reject boards perhaps. You know, they've tested them all out and go, oh, that don't work, that socket. Reject. The actual, everything else works. The volume control, the remote control bit all works, but that white socket for the relay doesn't work. So onto the scrap heap it goes, potentially for repair, but I suspect not. If they're making these by the millions, they might just reject them. And then they sell them on. I don't know. That's pure speculation on my part. Because Banggood are only selling this bit of it. They're not selling anything to do with that white socket for a relay. They say, in fact, there was a comment on that web page, there, this one, and somebody asked the question, what's that white socket for? Is it a relay? Well, the on thing, and the answer was not important. In other words, don't go there. But of course, everybody has gone there, and most people have got it working. So anyway, by resoldering that transistor, I've got it working too. So I'm thinking, what am I going to use it for? You know, switching my preamp, switching off the, I don't know, the active speakers I've got. I don't know. But there we are. It just goes to show that even, you know, buying stuff like this, you do have to have your wits about you and know a little bit about electronics and what could possibly go wrong. And as I say, eliminate everything, and what you're left with must be what's left. Yeah. So basically, I think this is pretty neat. This isn't, I'm not intending this to be like a promo video for this item. Banggood haven't asked me to do this at all. It's just something I bought because I wanted it for me in my workshop here, so I control my music rather than having wires everywhere. Oh, the range, by the way, on this is pretty good. I mean, I put this right at the back of my workbench, right back there, and I can point this in any old direction and it works. So I thought that was pretty neat. Yeah, so it's not a promo, but if you do follow the product link below the video or in the GitHub, no, there won't be a GitHub for this, in the promo link in the video description, it is an affiliate link. So if you click on it and then buy something from Banggood, my channel does benefit from that. That's how I make some earnings. So I can buy things like this, basically. And if that's only valid for 24 hours though, so if you click on it and then don't do anything, and then you go back in a week's time, I don't get anything unless you click again and then find something you want to buy. Not necessarily this product, anything. Once you click the link first, commission wends its way to my channel. It's only a tiny amount, believe me. So anyway, that's fine. So don't think of this as some big push for Banggood products, because whilst I love Banggood products, they're not asking me to do this at all. No doubt they'll be delighted I've done it, but that's a different story altogether, isn't it? Right, very, very quick update on my phone charger. Do you remember I said that I was having problems getting the charge current through? Let's just have a 2-minute update on that next. Right, 2-minute update on the phone charger. First of all, the APK that was up on my GitHub, there was something wrong with it, and I've tested it, and yeah, it goes, oh, I can't pass this APK, and I'm not surprised. Instead of being 5 meg, it was something like 328 bytes. So I've emailed myself the APK, and once again it got corrupted. I don't know what is going on there, but I've now, by hook or by crook, I've managed to get the proper 5 megabyte APK up on my GitHub, and I've tested it all. So yeah, you can download that now. Make sure that it is 5 meg when you get it though, and don't email it to yourself via Gmail, because they refuse that. They just go, nope, it's a dangerous item, I'm not going to let you email that, and they just reject it. So download it somehow directly from the GitHub. So there will be a GitHub for this video now. The only change I made, which I mentioned to you, was to take all this guff down the bottom. There's some text, because I think lots of phones are shorter than this, and then you'd end up with a scrolling screen. But that's the only change I made on that. Anyway, it works now, absolutely tested. Now, remember last time I said, look, I'm really worried about the current flowing through this thing. We're worried about sub-ohm resistance on that little SI4599 MOSFET, and yet there was massive resistance on all these sockets. So I've hardwired it in. As you can see, I've hardwired this one now to the phone. This little tiny short cable goes to the phone. That immediately improved things, not quite as much as I'd like, but then the cable that's originally here, hardwired to here, I've disconnected that now at the other end. I've plugged in my original cable that I've always used. Now this charges at 1 amp. Not always, it varies. Sometimes it goes, oh, I'm only going to charge at 500 milliamps. And then as it drops lower and lower and lower, if you then plug it in at, say, 40% full, whoomph, up it goes to 1 amp. And I think that's great. There's obviously something going on with the phone that decides how much it wants to charge, I'm guessing. But it does charge at 1 amp. The other thing I found is that instead of using my plug-in wall wart for this, if I plug in my workbench supply onto here, so a full 5 volts that does not drop no matter what, then that charges at well over an amp, 1.2 amps. So it's obviously the quality, I guess, of the plug-in wall wart here. But with this cable, which is much lower resistance than this one that's soldered on there, even though this one's going through that socket, I'm happy with that. So it's working. As you can see, there are absolutely cables everywhere, and you know, it's still a mess. But I am actually using this day in, day out. I am using this, and yes, it works. I've even tested. Somebody mentioned, hang on, if you're running this all day and you're hitting this button here that says done will run in background, bing, it's gone now, it's running in the background. I've checked the battery consumption of the APK, and it's really low. It's way down the list, 0.1% or something. So I've absolutely no concerns about the fact that that APK, that app, can be flattening the battery. I think not a chance. And if you're, somebody mentioned also, if you're away from your desktop or workbench or your whatever it is, and you think, well, I'm disconnecting now, and I know I'm going to be away for several hours, why does that app keep running trying to connect to Bluetooth? Isn't going to flatten the battery? Well, first of all, as I say, it doesn't flatten the battery, but I cannot turn off Bluetooth, nor can I switch Bluetooth on via an app. Google, Android will not allow it now. From Android 9.0 Pi, when an app wants to turn on Bluetooth, the user gets a confirmation saying, do you want to allow this app to turn on Bluetooth? So there's nothing I can do about that, and frankly I don't think it's worth it. The best thing to do, in fact, if you're going away, if you can remember, is bring the app back up, so it's like this, and then hit the exit button, so that one there, and go, yes, I really do want to exit this time rather than return to the app, and then it will be stopped, and that's the end of it if you're that worried. So yeah, I'm okay with this now. There's one extra feature that I'm hoping to add that has to do with electronics on here that I've not yet got working. Partly, I must admit, because I can't quite see what I'm doing, but in theory it should work. And I'll tell you what it is. Basically, it's a current sense resistor to determine when current is actually flowing down this wire, not this one, i.e. this is switched on, but is there anything actually connected? I know the Android app can tell whether something's connected, but there's a problem with that. It's not a bug, it's just the way things work out. But I want to know if something's actually flowing down this wire. In other words, have I really plugged it in? And to do that with a sense resistor is just proving slightly more awkward than I would have hoped or expected, but that's for another day. In the meantime, this is working exactly as designed, so I'm well chuffed with it. I'm designing a PCB for this, although that has its challenges as well right at the moment, but at least that's a nice thing to do while I'm locked away at home. So yeah, if you want to grab the APK and the Android sketch that I put up in that other video, that one, yeah, that one there, that's the link. you'll find it works for you as well as it does for me. And if you get that little SI4559 module, so you don't have to solder that little SMD thing on, it's already on that little purple board, and hardwire your USB cable, so don't use these little sockets. I know that one's working now, but I suspect it would work even better if it was hardwired. Yeah, it works great, and then you can do your own thing, or wait for me to finish the PCB, of course. Your choice. Right, that's it now. This was only a quick update, and yes, I know it's late because I've had a zillion things to do. Yeah, comments down below, please. That's good, and hope to see you in a future video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.